Or no, maybe you haven't seen function notation. Is anyone on this part A, can they already tell me what f of 3 is? What'd you say? 13 is correct, yep. When you're given a function, f of x equals 5x minus 2, anytime x is filled in with something, that's what they want you to plug in. So f of 3 means 5 times 3 minus 2. So you would write that. And again, when you're substituting something in, it's always good practice to put parentheses around it. And then you can just do that math in your head. 15 minus 2 is 13. Okay? Now, I will say this. This is your input. This is your output. This is your x coordinate. This is your y coordinate. So if you ever see, and I'll write this at the top and I want you to write it as well, if you see f of 3 equals 13, in Algebra 2 language, that means the same thing as the Algebra 1 language would be giving you the point 313. Input, output, that's a point on a graph. F of 3 equaling 13, 313 is a point on the graph of this function. Okay? Now on the second part, they ask you to do f of 2x plus 1. So we are plugging in 2x plus 1, wherever our x is. Okay? So they've taken out the x, they've replaced it with a 2x plus 1, so we're going to do that over here. 5, we're going to take out the x, replace it with 2x plus 1, and then minus 2. And then we're going to simplify, so we have to distribute and combine. So that's 10x plus 5 minus 2, and that's going to be 10x plus 3. Okay? Yes. Okay, so in function notation, let's go back to the 3. If they ask you for f of 3, they took out the x, they replaced it with a 3. So we took out the x, we replaced it with a 3 in here. We did the same thing here, although because it's longer, it does get a little bit more lost. They took out the x, replaced it with a 2x plus 1. So we're taking this exact function, 5x minus 2, and we're taking out the x and replacing it with 2x plus 1. Does that make sense? Good. Thank you. All right, we'll come back to these a little bit later, provided we have time, but it's just more of the same. Just they redefine new rules. Take out the x, replace it with a 3. Take out the x, replace it with an x minus 7. Okay? On a table, let's get the context of what's happening here. Boiling water at 212 degrees Fahrenheit is left in a room that is 65 degrees Fahrenheit. So you just took it off the stove and left it on the counter just to cool down, right? And it begins to cool. The temperature readings are taken each hour and are given in the table below. In this scenario, the temperature T is a function of the number of hours. That's your y coordinate then. T is your temperature, that's your y coordinate, and x is your h, your hours. Okay? And that makes sense because your cause is the fact that time is passing and the effect is your water is cooling. So there's your cause and effect. So it wants us to use the chart to evaluate T of 2. What that means is, what is the temperature at the 2-hour mark? So you go to T of 2, where they would have plugged the 2 in for H, hours, and T of 2 equals 104 degrees. Okay, so T of 2 equals 104. Now, it is not uncommon for you to be asked to interpret that. Anytime it says to interpret, that means what you've been given is in math lingo, and it wants you to interpret it and to explain it in English. So if I were to interpret this, I would say the temperature at the 2-hour mark, or at the temperature after 2 hours of cooling, is now 104 degrees. And what is T of 6? Connor. T of 6, go here, is 68 degrees. Very good. Okay? Now, going backwards, they say for what value of H is T of H 76? So essentially, they're giving you the temperature. They're saying the temperature at some hour is 76 degrees. The temperature at some hour is 76 degrees. What hour is that at, Cameron? The 4th hour, correct. H equals 4. If they ever wanted you to interpret that, you would say after 4 hours, our water has cooled to 76 degrees. Okay, so just being able to change that math lingo into something that's meaningful if you're talking to a second grader, right? Between what 2 consecutive hours will T of H equal 100? So when will the temperature, T, equal 100? If you look, obviously there is no 100 degrees on there, but between which 2 hours will it at some point cross over that 100 degree threshold? John. Very good. Somewhere between hour 2 and hour 3. So it's at 104 to start that span of time, and it's decreasing. It's got to pass 100 degrees at some point. So between what 2 consecutive hours? Hours 2 and 3. Okay? From a graph. So here's really 3 main things with functions. We have the function rule or the function equation. We could have a function presented to us in a chart, and does everyone see how none of these x input numbers repeat each other? Right? Otherwise it would not be a function. Okay? And then from a graph. So there's equations, tables, and graphs. Okay? When they ask you to evaluate f of -1, they're giving you the input, right? F of -1 equals, that's the x-coordinate. Tell me the y-coordinate that goes along with an x-coordinate of -1. So look at your chart, look at your graph. Find an x-coordinate of -1, which would be here, and actually the graph happens to go through here. What's the y-coordinate of that point, Connor? What'd you say? The x-coordinate is -1, comma 0. So f of -1 equals 0. Nice. Everyone take a minute on your own and look and try to figure out what f of 1 is. Isaiah, what do you think? Yep. Very good. And lastly, for f of 5, Aiden. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4. -4. Very good. Okay. Evaluate f of 0. So take a quick look at that. And what is f of 0? Evan. F of 0 is 1, 2, 3. Correct. What special feature is that? We talked about it really quickly at the end of class yesterday. That is called the y-intercept. Okay? So, I didn't do it last year till the month leading up to the Regents, but we will, let me show you, we will do flashcards this year. And here's the stack of flashcards, not those, these, of all vocab and quick little things that you need to know. And right now, honestly, we can do a lot of them. One of them is the y-intercept. And so I will show you the y-intercept on like a flashcard quiz, and you'll have to know to write down when x equals 0. And that's what this is. The y-intercept is when x equals 0. Whatever that number is, that's the y-intercept. Okay? And vice versa, the x-intercept is when y equals 0. Okay? And we're not quite there yet, but we will. So that is, a flashcard thing that I just expect you to flat out know within a second. If I say to you, y-intercept, you have to tell me x equals 0. Okay? There's probably a couple more I'll look through that you would be able to do already, but I'll look through that and give them to you by the end of the class if we finish here. Elaborating and going even further with this question, what does part C say? What values of x solve the equation f of x equals 0? So we want what x coordinates get paired with a y coordinate of 0. And these are our x-intercepts, right? The y coordinate equaling 0 is here, here, and here. So the values of x that correspond with a y coordinate of 0 are -1, 1, 2, 3, and 4, 5, 6, 7. What special feature on a graph does that give us? Those are x-intercepts. Okay? Before we go on to D, a very good explain question I could see coming up. Explain why in a function you can only have one y-intercept, but you may have multiple x-intercepts. Explain why in a function you can only have one y-intercept, but you can have multiple x-intercepts. Give people a minute to think about that. I see 2 people know so far, or are ready to share anyway. Only 2 of you? Isaiah and Lydia. Oh, we got another one. Bo? Bo, what do you think? All right, when we say explain, Bo, we want a complete sentence that makes sense. So it would start with, you can only have one y-intercept because the function needs to pass the vertical line test. Imagine if you had ever had 2 y-intercepts, like you had a graph cross there and there. If you are drawing a graph and it has to cross both of those points, you kind of have to go back around and grab it, right? And doesn't that fail the vertical line test? Because why? Because this would be the point 0, 4 maybe, and this would be the point 0, -2 maybe, and the x-coordinate repeats itself. So it cannot have 2 y-intercepts, but we have no problem having multiple x-intercepts because these points are -1, 0, 3, 0, and 7, 0. We don't care if y-coordinates repeat themselves because that doesn't make it fail any vertical line test. We only care if x-coordinates repeat themselves. Good? Okay. And last question here on D. Between what 2 consecutive integers does the largest solution to f of x equals 3 lie? Okay. So this is essentially saying your y-coordinate equals 3. Okay? Y equals 3 as a line is a horizontal line. So this right here is the line y equals 3. Okay? Do you remember in systems when your solutions come from the point of intersection? When you graph 2 lines, you're interested in their point of intersection. That's the solution to the system of equations. It's been a while. We'll review that. But that's what's happening here. You have a horizontal line at y equals 3. It wants to know what the solutions are. Okay? So we don't have an equation. They didn't give us a rule like this for our function. So it's not like we have an equation that we can just set equal to 3 and solve. All we have is the visual. And they want to know where this function equals this 3 function. And that is happening here at an x-coordinate of, that's an x-coordinate of 0, right? It's also happening here at an x-coordinate of, what's the x-coordinate here, McKenna? 3? Oh, no, that's the y-coordinate. We have 0, 3, with 0 as the x-coordinate. We have blank 3, 2. So that's x equals 2. And we have something here, 1, 2, 3, 4, 5, 6, 7, somewhere between 7 and 8, we'll say approximately 7.5. So there are 3 solutions to this. They are asking between what 2 consecutive integers does the largest solution, so which one is the largest? 7.5. In between which 2 consecutive integers? Integers just kind of means whole numbers, non-decimals. Either positive or negative, but in this case, what 2 numbers is 7.5 between? 7 and 8. So we would write between 7 and 8. Okay? So understanding that you have multiple solutions for when this function equals 3, because there are multiple places where the y-coordinate is 3. And you're looking for the different inputs that would make that happen, and then take the largest. Okay? Any questions so far? Okay. We have a function, g of x, y equals g of x. It is known that g of negative 2 equals 7. Which of the following points must lie on the graph of g of x? If g of negative 2 equals 7, which of the following points is on the graph? Take a minute to think about this. And you're choosing option 1, 2, 3, or 4. So I want everyone to raise their hand and hold up 1, 2, 3, or 4 based on which choice you're picking. So you all can put your hands up. Where's the rest of you? On the count of 3, you're all going to hold up a number. 1, 2, 3. Okay, good. This, most of you got it right. This is the concept I told you about right here. If this function value, the function value at 3 is 13, that is equivalent to the point 313. So this negative 2, 7 is negative 2, 7. Number 2. Good. What do we have for number 5? Okay. You guys hate word problems, but you shouldn't, because word problems are usually pretty good at telling you exactly what to do. You just have to be not be afraid of reading. Maggie, could you read number 5 out loud for us, please? Okay, so good, thank you. The first thing I also want to point out is that height is a function of time. So height is your y-coordinate, and it's a function of time. That's why time, t, is being used in parentheses. Okay, and then your equation is written with t, with respect to t. So your height is dependent upon how much time has passed. Okay, so using our calculator, let's type in 50 minus 16x squared. If you do not have a calculator, do not wait for me to catch you and then have to tell you to go to the back of the room to grab one. Go grab one on your own. So I can't use T or H on my calculator. Obviously, we have to use X. Okay? So type that in. It wants us to use our table. Now, when we're setting up our table, given that my X coordinate is time, or actually when I'm setting up my window, because we'll set up our window, our X coordinate is time in seconds. So what's the lowest number of seconds that's even going to make any sense? 0. And then how long do you think it's going to take a ball to drop to the ground? How many seconds? From 50 feet up. That's what it said it started at. 7. Okay, 0 to 7. The point is it's not 150, right? And then y is our height. So where is our ball starting? 50 feet, right? Now, is someone throwing it or just straight dropping it? It says they're just dropping it. So if they were throwing it, they could throw it up from 50 feet. So they're on top of this building that's 50 feet. It seems like they're just dropping it. So it's going to start at 50 and only go down from there, right? And what's the lowest height wherever? Ooh, I did that backwards, right? The lowest height is 0. The highest height is 50. Okay? So that gives us a good, this one, now when I hit graph, this should give us a pretty good look at what's happening. Here's the ball starting at 50 feet, dropping. So visually, when is it hitting the ground? Between 1 and 2 seconds, really closer to 2 seconds. So if you had to guess, 1.8, 1.9 seconds, right? But this wants us to use our table to determine to the nearest tenth. Now here's where setting up your table, like we talked about yesterday, is critical. We know it's already visually happening between 1 and 2 seconds, right? So really we need to look in between 1 and 2 seconds. So I'm going to start my table at the 1 second mark. I want it to the nearest tenth. So I don't want to count by ones because then my table is going to show me the 1 second mark, the 2 second mark, the 3 second mark. I want to look more closely between 1 and 2. To the nearest tenth, I'm going to count by tenths, 0.1. Are you doing this? Okay. So now when I hit second and go to my table, it's going to start at the 1 second mark and it's going to show me the height at 1.1, at 1.2, 1.3, and as we know is happening, it's decreasing. So when to the nearest tenth, when is it closest to 0? So it happened somewhere between 1.7 and 1.8, didn't it? See how it crossed 0? Which one of these numbers is closer to 0? This one's 3.76 units away from 0. This one's 1.84 units away from 0. This one's closer. So my answer is 1.8. T equals 1.8 seconds. When it says provide tabular outputs, it's really just asking you to share the key part of the table. So that would be 1.7 with 3.76. And again, this is our time, these are our heights, and 1.8 with negative 1.84. Okay? Now, let's pretend we weren't going to use a table, we were going to use the graph to do that. So go back and hit your graph button so we're all looking at the same thing. I'm going to turn this. Oh, it's a... There. How's that? Okay. So how would we find from the graph when it hits 0? Does anybody know? If we wanted the exact answer to the nearest thousandth or something, yeah, go ahead.
Would you go to like hit second trace?
Yes, trace is a very key menu. Second trace, okay? It is a 0. A 0 is any place where the graph crosses the x-axis. So we could go down to 0, do that with me. We definitely will be interested in this. This is going to be an x-intercept. We hit 0. Your calculator asks you for a left bound. Don't hit anything yet. Don't get button crazy and start hitting stuff, because then you'll get away from what we're doing. And right now, you don't see it, but my cursor is at 3.5, negative 146, which on my graph, 3.5, negative 146 is way down here, right? Technically, the function continues, even though in the context of the problem, the ball doesn't continue dropping. Okay, but it's down here somewhere. It's asking us for left bound because it wants us to bring our cursor to the left of the 0. So knowing that my cursor is currently at this location, which is way off the graph, I'm going to hold this button down or keep hitting it over and over again. And my cursor, again, you can't see it. It's off the screen. There, it popped back on the screen. You see my cursor now? Okay? And now it tells you the coordinates that I'm at. It's to the left of the 0, so then I'm okay for my left bound. Hit enter just one time. And then the words at the bottom of the screen changed to right bound. So now it wants my cursor to the right of the 0. So I bring my cursor and I start scrolling right until I get into the negative, so I know I'm below that 0 threshold. And then I hit enter again. And at the top, you'll see 2 little arrows. What you did is you told your calculator between this very point and this point, it's going to find a location in between there where it hits a 0. And it's going to say guess, which you're not going to guess anything. You're just going to hit enter one more time, and it's going to give us the exact time when our height is at 0. 1.76. Is that a 3? My cursor's on so I can't see. 1.767767. So to the nearest 10th, we nailed it, right? 1.8. We got that info from the table, but you can also get it from the graph. Okie doke. All right, the last section at the bottom here. Taking function notation and performing operations. So let's actually do B first. It wants you to take f of x. F of x is 2x minus 1. So I'm going to replace f of x with 2x minus 1. Again, always keeping parentheses after it. And I'm going to subtract g of x. So I'm going to replace g of x with x squared plus x minus 2. And then simplify. So we have to distribute the negative is all to the second set of parentheses. That's going to be 2x minus 1 minus x squared minus x. What happens when you subtract a negative 2? Turns to plus 2. And then we're going to combine like terms. For our x squared, we have nothing to combine it with, so our first term is just negative x squared. We have a 2x minus an x. That's going to make plus 1x. And then negative 1 plus 2 is positive 1. And there's f of x minus g of x. And we're going to do C. I got a minute. Did you already do C? No. We're going to take f of x, 2x minus 1, and g of x, x squared plus x minus 2, and we're multiplying them. So what's 2x times x squared? 2x cubed. 2x times x? 2x squared. 2x times negative 2? Negative 4x, right? Then we distribute our negative 1 through. So go ahead and do that. And then combine like terms. And I'll ask a lucky candidate for the right answer when we have minus fish. Anybody have the answer? Yeah, go ahead. Plus 2, did you say? Yeah, I think that was it. So I'll finish that one quickly on the video, and then you can check it. Your homework you all now have.
I have the decomposing one.
There's the answer, so it will be on the, thank you. That will be on the